Assalamualaikum and a very good day. This is our group project video about spring-back effect. What is spring-back and what is the factor that affect this phenomenon? While I'm explaining, the visual will show the progress of spring-back simulation. According to plastic deformation theory, the material is generally divided into two zones, the elastic zone and the plastic zone. The elastic property tries to maintain the material in the initial shape, whereas the plastic property tries to retain the material in deformed shape. In the sheet metal bending process, the bending load increases until the elastic limit of the material is exceeded, and then the material stays at the plastic deformation zone. The outer surface of the material generates the tensile stress, while the inner surface of the material generates the compressive stress, and it's propagated inward and toward the neutral plane. Because of the stress distribution, this phenomenon causes the formation of small elastic band around the neutral plane. As the bending force is removed at the end of the bending stroke, the inner surface generates compressive stress try to enlarge the workpiece, and the outer surface generates tensile stress try to shrink. In contrast, the elastic band remains in the bend part, trying to maintain its original shape, resulting in partial recovery to its initial shape. This elastic recovery is called spring-back. What is the factor affecting spring-back effect? There are some important factors which affect the spring-back effect in the forming operation of metal sheet. The first one is punch angle. Punch angle is the angle of deforming tool which is used to deform the sheet metal in forming operation. Depending on the required shape of the product, the punch may be having a V-shape, U-shape or curvature shape. The next one is grain direction of sheet metal material. Grain direction of sheet metal material plays an important role in the forming operation. Sheet metal material having uniform grain size and direction give the better result as the deformation is uniform in the required direction. Next is die opening. The forming operation are carried out on the press machine with the help of the punch and die. Sheet metal is placed on the die, and by applying force punch deform the sheet metal. To obtain the desired shape of the component, the dies may have a V-shape, a U-shape or the curvature shape. The next one is sheet thickness. If the sheet metal thickness is less, there will be more spring-back, and as the thickness of the sheet metal increase, the spring-back of the metal decrease. For the same material of different thickness, the spring-back effect is also different. Next is punch nose radius. The total deformation of the sheet metal in die depends on the punch nose. If the punch nose radius is increased, the punch will not travel up to the end in the die valley, and this also affects the spring-back of the sheet metal. So to reduce the spring effect of the sheet metal, the punch nose radius should be maintained correctly. And the last one is the punch height. The punch height is a distance traveled by the punch to deform the sheet metal. By calculating the required force for deformation, the punch height can be calculated. It also affects the spring-back effect, so it is necessary to calculate the correct punch height. The total deformation of the structural steel can get 15.075 mm maximum. The middle of the lamella is focused by the maximum stress of total deformation, where the pinball punch 0.1 mm in radius, pushing the lamella into the die purposely to bend the lamella according to the shape of the die. However, it is observed that the result of the bending does not perform the lamella to bend accordingly to the die shape. By the maximum total deformation, which is 15.0075 mm, it is found that it was not enough total force applied from the punch to completely bending the lamella into the shape of the die. More total force should be added to obtain the full bending of the lamella to the die shape. The problem that we observed in this simulation was the lamella thickness are way too small. Increasing the lamella thickness to 5 mm would reduce the effect of the spring back. In this case, the lamella thickness was less. That is why the spring back is tend to occur more than the higher thickness of lamella. The spring back occur might only happen because of the less thickness of the lamella. However, the result of the spring back not only caused by the thickness of the material, but it is also can caused by the material itself. In other words, different material has different result in the spring back effect. Pinball radii also give influence to the spring back phenomenon. The radius of the pinball should not be higher than the bottom of the die. The radius of the pinball that is located and the punch nose must fit to the smaller radius at the die. This is because if the radius of pinball is high, the punch will not arrive to the end of the valley region. In this case, the radius of the pinball is correctly selected. However, in this experiment, the deformation of the lamella to the die design is failed because the punch distance was not able to deform the lamella into the die design. For the future study, our recommendation are to increase the thickness of the lamella into 5 mm and the maximum force need to be increased to make full deformation of the lamella into the die valley.